All right, let's talk about 3.4, solving special systems. So these are going to be ones that have like unique scenarios. So just kind of show you what I mean. Like, let's take a look at number 1. If I was to graph both of these, notice they both have the same slope. What does that mean? Well, let's just take a look. If I was just sketch a quick graph, and we'll go down 4, 1, 2, 3, 4, and we'll go up 2, 1, 2, and I'll graph this one in red. I would have a y-intercept of -4, and the slope would go up 1 over 2, so it would look something like this. All right, well, let's say I graph this one in blue. It has a y-intercept of 2. It's going to go up 1 over 2, and it's going to look something like this. And you can see, if they have the same slope, these lines are going to be what we call parallel. That's a very important word, very, very good vocabulary word that you'll see used all throughout life. Parallel. And it means that they will go at the exact same rate or the same slope forever and ever and ever. Well, they'll never touch, right? These two lines will never, ever touch. And so this would have no solution because the lines are parallel. So anytime you have the same slope, you're going to get no solution. Unless they're actually the exact same line right on top of each other. If you end up with the exact same line, then it's not no solution, then it's infinite solutions. So let's take a look at this next problem. So we could graph it, but what I would do instead is I would just get these both in the same form. This one's already in standard form, so let's just add 5x to both sides and get this one in standard form as well. We got 5x plus 3y equals -3. Well, hopefully you notice 5x, 3y, 5x, 3y. When you're in standard form and your a and b are the same, you're going to have the same slope. Because remember, I told you guys that slope is always -a over b in standard form. So -a would be -5 over b is 3. And down here, also -a over b, it'd be -5 over 3. They have the same slope. So what do we know? We know there's going to be no solution because these will end up being parallel lines, just like it was in number 1. They're lines that will go on and on forever and never touch. So we can just know that if they have the same slope, they're always going to be no solution. So here's your 3 different outcomes. This is what we just talked about, the no solution with parallel lines. This is what you're used to. This is what we did with 3, 1, 3, 2, 3, 3. We got the 1 solution. And then this is infinitely many solutions. What this means is there are actually 2 lines right on top of each other. So the lines coincide. So you really wouldn't see them, right, because they're right on top of each other, but they are. There's 2 lines here that are the exact same line. And that one we say infinite solutions because literally there's infinite spots along that line where they're the same. All right. So let's try this one by graphing. I want you to just try it. Just take a sketch real quick. The only thing I would say before you do this is you might want to get this y all by itself first. So that's no problem. We could just add 3x to both sides. And then this equation would be y equals 3x plus 1. So sketch a graph of this and just see what happens, and I think you'll see what's going on. All right, so if you would have sketched a graph, you would have seen you get 2 parallel lines, and therefore we know this is a no solution. Anytime you have the same slope, you're going to get no solution, okay? All right, on this one, let's take a look at what happens when we try to graph this one. Obviously, one of these is not in the right form. This is in the y equals mx plus b, right, this top one. But this bottom one's not in any form that we like. But what we can do is we can get it into standard form. We can get into standard form by just adding 8x to both sides. And then we could rewrite this in standard form. It would be 8x minus 2y equals 2. So we're going to use that one to graph because we can graph with intercepts. Let's sketch our graph over here. If I do this one, let's do this one in red. Okay, my y-intercept is -1 and my slope is +4, so it's going to look something like that. All right. Now let's graph this one in blue by the intercepts, right? Remember, by the intercepts, I plug in a 0 for x. If I plug in a 0 for x, this whole thing turns to 0. And I would just be left with -2y equals 2. Divide both sides by -2. You get y equals -1. Hey, I have a y-intercept of -1 as well. Interesting. Okay, then I'm going to also plug in a 0 for my y, when I do that, this whole thing disappears, and so I have 8x equals 2. Divide both sides by 8, and I get x equals 2/8 reduced down to 1/4. Well, 1/4 would be this exact spot if you think about it, because I'm going up 4 over 1. So these 2 points would be exactly the same. So if I connected these dots, I'd have another line right on top of this one. And in fact, if I would have I didn't do this because I didn't want you to see it right away, but let's take this equation now and let's come over here and just think about it. What if I would have just divided everything by -2? What would I have gotten? Well, I would have gotten y equals -8 divided by -2 is 4x, and then 2 divided by -2 is -1. It's exactly the same equation. So that's why we get duplicate lines right on top of each other. All right, let's go to the next page and see what this looks like when we just do it algebraically. All right, so for number 5, we're going to actually solve this one by substitution. And that's easy to do because the y is already solved, right? So I can just plug that in. So I got -16x plus 2, but instead of y, I'm going to put 8x minus 1 equals -2. All right, so I distribute this 2. I got -16x plus 16x minus 2 equals -2. -16x and +16x cancels out, and I'm left with just -2 equals -2. That is an indicator that we have infinite solutions. Anytime you get down to an equation that's exactly the same on both sides, that's infinite solutions. It's true, -2 equals -2, but so what? That doesn't give me any information. And I won't get any other information because there's infinite things that we could say that are true. Just like -2 is -2, could I also say that 1 equals 1? Could I also say that 3 equals 3? And so on and so on and so on. Yeah, there's infinite things that make this equation true. Therefore, there's infinite solutions. All right, but let's take a look at number 6 and see another situation. This one says solve by elimination. Well, we're not really ready to eliminate anything yet because we need some variables to cancel out to do solve by elimination. But I can see that if I multiply this by 6, 3 times 6, I'd get +18, and that would cancel that out. So I'm going to go ahead and multiply everything by 6, and I'm going to just write it right here. So 6 times 3 is 18x, 6 times -y is -6y, and 6 times -2 is -12. All right. So now, if I was to add these equations together down here, what would I get? Well, -18x and +18x, that just makes 0. And +6y and -6y, that also just makes 0. And then over here, I have 24 and -12. That makes 12. Well, 0 plus 0 does not equal 12, does it? Okay, so when you get something that is not true, that means that we have no solution. Okay, so those are the two things, those two weird situations you might run into when solving it algebraically. You're either going to get a number equals itself, that's infinite solutions, or something that's obviously not true, and therefore that's no solution. All right, and I kind of put that here in a chart for you. So no solution graphically, it's going to have parallel lines, and the variables will cancel, and you'll get sides that aren't equal. One solution, the lines intersect exactly once, and each variable has a single solution. Infinitely many solutions, both lines are the exact same when graphed, and the variables cancels, but the sides are equal, right? Like, for example here, like this would be like, well, not x equals, this would be like 2 equals 0, which is not true. This would be like x equals 3. Hey, that's good, that makes sense. And this would be like 3 equals 3, right? That doesn't give us any help. All right, that's it for this video. I'll see you guys on the next one.